All right, well, today's presenter is Jim Holden. Jim is the product manager for pressure here in North America for ABB, based down in Bartlesville, Oklahoma. Jim joined ABB in 1999. He's held a number of positions, including test engineer manager, production manager, and even supply chain manager. He began product management in 2014 as the product manager for field instrumentation devices in upstream oil and gas before taking on this role right now to manage our pressure products here in North America. So thank you, Jim. I'm going to turn this over to you. I know all of you are going to enjoy today's presentation.
Well, thank you, Wayne. Welcome, everyone, and good morning or good afternoon or good evening, wherever you might be. So what you've registered for is what's on the screen right now, and I will try to be going over quite a bit of material. It is somewhat technical in places, but trying not to be too technical. It's a lot to cover, so I guess we will get started. And if you're not registered or didn't plan to learn something about pressure transmitters and ABB pressure transmitters, then as they say on the airlines when you board, it's time for you to get off right now. So hopefully you'll enjoy this. From that, the agenda I have is the following. We're going to talk about pressure measurement, the different types, technologies, units of measure, accuracy, some of those issues. We're going to then talk about the components that make up pressure transmitters, then go into applications. There's a lot of different industries that ABB serves with very big variety of applications. And then we'll get into the questions that Wayne was talking about. So in pressure measurement, first, there are different types of pressure measurement. If you know, there's basically three different types. I've added multivariable as a fourth type, but an absolute pressure transmitter is kind of like it says, it's measuring absolute, which is against a vacuum. So it's basically if there's no pressure, and you would measure atmospheric pressure, which is what a barometer is. If you have a gauge pressure, you're actually measuring the pressure against that atmospheric pressure. So if you were using a gauge pressure like a tire gauge, which is very common, you have 32 pounds per square inch of pressure. If you were measuring that same tire pressure with an absolute pressure transmitter, it would be an additional 14.5. So those are kind of the basics of the types there are. And then there are the differential pressure. On differential, you're measuring the difference between two different pressures, and that's the reading you're getting. Now the multivariable is another one, and it includes measuring the difference between one of the pressures that is static, and it also measures the process temperature. So that's the different types of transmitters. The technologies that go into those, there's a lot of different ones, and that would get pretty technical to go through, but you may hear terms like piezo or piezoelectric crystals. That's what's changing the pressure into an electrical thing that we can work with. There's inductive type of ones that are actually better for harsh environments, for shock, vibration, those types of things. There's bridge, sometimes called strain gauge, which are usually used for high pressure. And there's pneumatic pressure transmitters also. So ABB does all these different pressure transmitters, and we'll talk more about that in a bit. When we get into units of measure, there are a large list that you can see there. Some people, depending on the country, depending on the application, depending on whether you're measuring high pressure or low pressure, or measuring something like level, you will get into these different pressures. An example there, 1500 PSI is the same as 100 bar. And if you have a 15-foot tank, like I'm showing in the diagram there, and it's a closed tank that you're measuring with differential pressure. That tank is 180 inches, and that's only about 6.5 psi. So there's another example of the units of measure that can be used. ABB pressure transmitters, depending on the one you choose to use, also have direct application software loaded on it, so you'll get your levels. The accuracy of the pressure transmitter can be affected in a lot of different ways. There's temperature effects, the compressibility of the gas or the liquid or whatever that you're measuring. The main thing that it comes from is how the transducer is constructed, the transducer that's in that transmitter, the quality of the electronics that are in it, the way that the manufacturer calibrates and characterizes the electronics with that transducer sensor. So there's a lot of different ways, and we'll talk a little more about accuracy. You'll see accuracy listed in data sheets as a percentage of the calibrated span. You may see it as a percentage of the value that's read. So those are kind of the basics of pressure measurement. Here's one example of a accuracy example. So ABB produces a multivariable, the 266JST. And if you look at an Emerson one or a Foxborough one, you may see percentage of span or the percentage of the value. Sometimes it's a mixed. On the ABBs there, you have 0.04% plus or minus 0.04% of the value, and that's up to a 20-to-1 turn down. So if you have a 1,000 inch transmitter and you're turning that down to smaller readings, you're still going to have that type of accuracy. For the static pressure, you have a very low plus or minus 0.05% of the value. And again, turn down range can affect the accuracy and those types of things. You'll hear a lot of people advertise with things like turn down range. So that's just one example of accuracy. The next thing I want to move on to is to know a little bit more about the pressure transmitter components, the process connections that you're connecting to whatever your industry application process is, the transducers, the signals that are available, the user interfaces. Those all become part of what you're selecting as a pressure transmitter. So the process connections in a simple pressure transmitter, you can have threaded types like an NPT thread. You can have a direct mount. You can have, often you're using some type of a manifold that you're mounting to. You may be mounting to a tank that has flange connections. You may have a process with debris in it that you don't want to go into the bore diameter of the pressure transmitter, so you may use a flush mount. There's different bore sizes. If you get into really high pressure, there's different thicknesses of metals and different machining. And in a chemical application or others, you may need anti-abrasion coatings in pulp and paper. You may be in food and beverage or pharmaceutical where you need hygienic connections. So those are all different types of process connections. Another thing, if you go beyond maybe some of the standard applications, you might need to remove to a remote seal. So the remote seal is as pictured there. You're basically taking that pressure reading through a remote seal that is put into the application. Then with a capillary tube, you're running to the actual transducer. With the ABB pressure transmitters, the entire sensor capillary diaphragm seal doesn't have any gaskets or any threads. It's an all welded all the way through and tested throughout all those welded connections. So there's no chance of any type of leak. The all welded technology is recognized globally for the delivery performance and stability over time. And ABB does this completely through all the remote seals at no extra charge. It's just what we do as standard. With the remote seals, you can get into extreme temperatures. So standard that I was talking about on the previous slide maybe is minus 40 degrees to 250 degrees. But depending on the remote seal you choose, you can get down to minus 350 degrees, all the way up to 750 degrees F. So temperature extremes can be used with the remote seals. There's many different types of remote seal coatings or remote seal metals that can be used if you're in a corrosive or hazardous fluid. If you're in solid laden or dirty or viscous fluids, there's also different types of materials that can be used. There's fluids with a tendency to crystallize. There's vibration that you might have to overcome that you can do with a remote seal. And you might be in a situation, food and beverage wise, where you have to meet FDA requirements. And we do have the fill fluids and the inert fill and oxygen service and different types of things to meet all those industries. As you can see there in the diagram that I just added, those are the different points, the different connections that with some manufacturers you will find threaded or different types of seals, which over time may end up presenting a problem. But with ABB's 100% well-bought roted seals, remote seals with the transducer, you don't have those issues. Another thing to talk about in this heart of the transmitter is the transducer itself. So there's a wide range of pressures, and when you look at a specification sheet or what you want to choose for your transmitter, you can have process pressure, which is typically what you're talking about, but you also may need to pay attention to the overpressure, where you can overpressure it. You won't be getting the reading, but you won't damage the sensor. It'll come back down and still be operational. And there's a burst pressure, which for safety wise, you need to know to make sure there's not going to be any kind of a break in and leaking of the process. There's material choices: stainless steel, Hastelloy, Monel, Econoline, Inconel, different types of materials that can be used in a transducer, and a lot of different fill fluids such as silicone, the Galden, and the halocarbon. The next thing you looked at in choosing a pressure transmitter is what kind of communication you're going to do with that electrical signal. So if you're going into an RTU or you're going into some type of a SCADA system, do you have analog inputs? Are you going to be talking digitally to it, or what are you going to do there? Some of the very common ones that you'll see are a Hart 4 to 20 milliamp. ABB offers standard and advanced. So if you have a simpler application, standard is a easy setup. The advanced, you can get into more of the applications that I was talking about, like level measurement. The 1 to 5 volt low power is another analog signal that we offer. If you're out in a remote application with a battery and solar panel or something where you need low power. There's wireless that you will use with a gateway. We're starting to do more and more business these days in wireless. Or let's say there's an older application site or a system that's already in place and you need to add some pressure transmitters to meet a certification or to replace something, enhance your system. There's a good option there. You can just use wireless so you don't go back through the wiring, or if you're out in a field, you're not going back through the trenching. And all of the above there have the Hart communication as well. The picture shown here is the Modbus. So Modbus digital communications is popular depending on the industry. This one shown has clear wiring instructions where you'll see where to put your power, where to put your communication lines. This one is for a Modbus multivariable, so it also shows the wiring instructions for the RTD that you would be hooking up. With the ABB pressure transmitters, you will see very clear graphics of what you need to do as far as the wiring goes. Some industries also use foundation field bus and Profibus. So these are some examples of the different types of signals that you'll be running into. The user interface, I'll go through a couple things here interface-wise. So the ABB interface is common across all the 266 pressure products, as well as many of the other ABB products. You'll see that same 4-button screen. It's very intuitive and multi-language. I usually tell people it's like my Timex marathon lap watch. It's got 4 buttons, and even if you have never used it before, it's pretty easy to go through it and learn how to use it. And it also includes an easy setup menu. When you go into the easy setup menu, it steps you through the basic half a dozen or so things that you need to do and be off and running. Then there's additional menus you can go into if you're setting up more elaborate things. With ABB, you have through the glass technology as possible. So if you're out in an environment where you don't want to open that pressure transmitter up, you don't need to. You can go right through the glass, and you don't need a hot work permit if you're in an explosive environment. So there's a good advantage with the through the glass technology. It just offers quick, safe, easy access. So when you go into the communication of the easy setup menu, there's the guided setup like I talk about. There's the configurations that you can do. You can set upper level limits and lower level limits. If for some reason you overpressure or have something, there's diagnostics that you can drill down into. So basically you have this easy setup as shown here. If you're buying an advanced pressure transmitter, you can set up the display, the alarms. You can go in and do a calibration, etc. And again, here's some other examples of products that also use those similar menus. Another information interface that you can do is becoming more and more popular. If you work out in the field, you know there is heart communicators and different ways that you can hook up to a pressure transmitter or other field devices and actually talk to the unit instead of going through the local keys. And what ABB now offers is called the Field Information Manager, FIM. And it is a free download software that you can load. You have the DTMs and things for the different products, all of that free of cost. You can do HART or Profibus or other types of communication. There's easy ways to manage the assets that you have and the things connected to there. It's Windows menu driven, very easy to get around in. So it's compatible with a lot of different things, and this is a product that continues to develop and have more added to it. So if you haven't checked out the Information Manager, I strongly suggest you do. So the next thing I will go into is applications, to look at the types of applications in the different industries and some of those examples in the limited time we have left. But first, I'm going to go ahead and go into what Wayne was talking about for the question and answer.
All right, thanks, Jim. We're going to take a quick poll. As I mentioned, this is totally anonymous. It will not retain who answered which way here. We will not have that information to pass along or anything about it. So it's just for Jim's kind of information, know who he's talking to today, and all of you will see the results. So the question, and I'm going to start the poll, is what has been your exposure to ABB pressure transmitters? You'll select 1. this is my first time learning about ABB pressure transmitters, or I'm familiar with them but have never used one. I've used them in the past but not presently, or I'm a current user. So just go ahead and vote right now, and I'm going to launch the poll. There we go. And just select your one answer. We're giving Jim a chance to take a little drink of water here, basically. And Jim, by the way, a couple of times your volume faded a little bit. You may have been looking at your other screen, so
Okay.
got to keep you close.
All right. Thank you, Wayne.
All right, we got people answering. I'm going to watch it for another 10 seconds or so and just go ahead and stop. So if you haven't put your answer in, do so now. It's great. We have almost 70% participation. All right. I'm going to allow everybody to see the poll. I'm going to end it and share the results with everyone. So interesting. My first time learning about it is the leader there. And the next group is those who are familiar with ABB but hadn't used one before. All right, well, great. Thank you, everyone. And what I'm going to do now is just turn this back over to Jim to continue. And Jim, you know, I would go until about maybe 10:35 or 10:40, and then we'll do some questions, okay?
Okay. Thank you, Wayne. And thank you all for supplying us with some information there. So moving on to the next slide. We have applications. I'm going to quickly go over, you know, there's so many applications for pressure transmitters in all the different oil and gas and chemical, power, pulp and paper, water and wastewater, food and beverage, you know, even marine, there's applications for pressure transmitters. There's a lot of different choices in pressure transmitters and a lot of different reasons to use them. One of the primary reasons is safety, to make sure a process isn't out of control, or to make sure there's not going to be any kind of an explosion or those types of things. Custody transfer can be an application where you're buying or selling if you have a loading station or something like that. And then automation is another one, to automatically control processes without as much human interface. So in the gas and oil industries, I'm not going to read through all of these, but again, here's kind of a layout of a site in the field where you're going to have safety systems. You're going to have some basic pipeline, tubing, and casing measurement. You can get into plunger lift, which I'll talk a little bit more about. Valve controls, you know, we interface and we take these pressure signals into a unit that then does something with that, controls something, open and closes a valve, or those types of things. So one is with a multivariable transmitter, can be used to collect precise data when you're talking about expensive chemicals or expensive hydrocarbons. You're going to use this for royalty exchange. There's a good example. We have high accuracy measurements going into an RTU and giving you just that information. A multivariable in a hydrocarbon pipeline application uses what's called an orifice plate to measure the pressure on each side of the orifice plate. That's what gives you that differential, as well as your temperature. Another application would be plunger lift applications. As a well grows older, you may need to use a plunger or do injections or those types of things. ABB is a great solution there. You can measure the casing and the tubing pressure and the line pressure and actually control that plunger and apply the application of more pressure and those types of things. So we could go up to high pressures as needed for that type of an application. The chemical industry, again, the biggest thing is safety systems. There's a lot of alarms needed. Shutdown systems can be used, so you can automatically shut down a process if necessary. You have control loop monitoring, you have cooling towers, you have steam and natural gas storage. Maybe it's in a tank that you're doing level with, or measuring the pressure going through a pipe. ethane production, ammonia production. There's a lot of pressure transmitters used in ammonia production processes. You go to the power industry, you can have measurement of flue or the burner gas, condensation pressure level, combustion chamber. You know, if there's pulverized coal processing, if there's boilers, you're going to have water feed and steam pressures coming from those. The draft that you may get, whether it's induced or forced, you got in and out flow from a turbine. You move on to something like this where you're measuring the gas. So you need high performance measurement to control the fuel and the combustion. So the ABB solution, we have very low pressure ranges that you can use to control that's going into there. Differential pressure you can use to adjust the flow or to cut off the flow. In pulp and paper, there's level measurement throughout pulp and paper, whether that be decomposition, whether that's the vats that you're using or the water tanks, the level measurement for the different auxiliary products that you're using in that production, the pressure measurement on the disc filter, the differential pressure on the drying cylinders. There's just a lot of different things in the pulp and paper industry that ABB has applications for, and there's a whole presentation separate on just this topic. So if you have more interest, we can definitely talk a lot more about that. Here's some examples of what ABB does. If you have abrasion, suspended particles for pulp and paper, you can use Diaflex. If there's corrosion, you can use Super Diaflex, or the Inconel. You can use it for vibration and humidity. We have the 261 product that is sturdy, compact, and can withstand all of that. If you have specific connections, we can use a remote seal or design what you need for the product. Here's the water and wastewater, where you can see the typical plant here. You have pumping and boosting stations, filtration, sediment, gas storage, leak detection. As you go through, there's just a lot of different applications. Here's one for the water where we're going to use Super Diaplex in this application. The availability is there with the Super Diaplex stainless steel alloy. Monel can also be used for water and wastewater as another alternative, and you can see there some of the examples of those remote seals. In food and beverage, same thing. We have, like I mentioned before, things that are FDA approved, the different types of processes, heating, cooling, the fill levels. We have the sanitary connections. We have the 3A metal surfaces. We have very good vacuum performance with our all welded seals. And a lot of times you're going to be using in food and industry clean in place or sterilization in place. And we have products that withstand, and you don't have to do anything different when you use those processes. So that was a quick run through of applications, but like I said, there are so many applications in so many industries that ABB covers pressure transmitters for all of those, and would be happy to go through those in more detail. The next slide, I just want to go quickly through a little bit more about ABB pressure transmitters if you didn't know. Right now there's 5 different factories in the world. So in Bangalore, India, Shanghai, China, Succio, Italy, Bartlesville, Oklahoma, and Warminster, there are factories that are producing these many units. Every year there's 150, 200,000 pressure transmitters sent out and put in to the industry with these 5 factories. When you look at the model code selection, And I was keeping things fairly simple, but ABB has a couple of different product lines. Two of the primary ones are listed here, but there's additional ones such as the pneumatic sensors also. So there's a lot of choices, a lot of different model numbers, and a lot of different pressure ranges that you can use. So we have something to fit what you need. Here are the basic ones that I mentioned earlier: the gauge, the differential, the multivariable, and the stainless steel. ABB's has a lot of advantages that you can list here. I think I've mentioned most of these, so I'm not going to read through them, but like when you get into a process, we are certified. So we're certified in all the different types of industries listed there. There's recent new products, so ABB continues to develop and add products. So there's a new product that we released late in 2018, which is a mass flow measurement type of multivariable, which communicates with Modbus. And it's great for level measurement and other types of things. We have a new one released just the end of last year, so a month ago we had another release come out, but it's great for things like an ultrasonic meter. You can have the pressure and temperature in just one simpler, low-cost device. We offer surge protection with the instruments and a lot of different things. One that's coming out that you'll be hearing more about soon is the new PSX 100 pressure transmitter, which will be a very compact, easy to use, has all the different process connections, has a backlit display option. So just keep in mind that ABB is developing new things. So if you haven't heard about or seen what you've needed recently, there's new products, or ask a local representative, and I'm sure there's something available. The easiest way to find out more information on your own, if you choose to do that, you can just Google ABB pressure measurement, and it will take you to the pressure measurement website. And there you can go through and you can look at the measurement types. If you know what you're looking for, you can go in and look and pull up your industry that you're in and what application you want for the industry. So there's a lot of good information there. So in summary, I went through very quickly a lot of different things here, but there's many pressure transmitters out there, and there's systems that need those pressure transmitters in all these industries. So like choosing an automobile or choosing a computer, you first need to know what your requirements are, and then you need to go out and look at what products are available and buy the right product. You don't want to buy a product that's going to measure 1,500 PSI or 15,000 PSI. If you want to measure a tank level, it's going to be more like 6 or 8 PSI. There's definitely cost-effective, field-ready, certified, easy-to-use answers with ABB. So when you have a requirement, I strongly suggest you check out ABB, because you may not be aware of all of the solutions that we have. And when you choose ABB, you will get a quality product, a competitive price, a good high-end product, and you'll have a very supportive team that'll work with you. So I appreciate your time, and if you need to get a hold of your local contact, you can also easily go to abb.com contacts to find someone, and feel free to send me an email, and I think we'll move it over to Wayne for questions.
All right, well, we're going to go through these for those of you who are still on the call, which is pretty much everybody. We're going to only take a few minutes. We've got 6 or 7 good questions. First question up, how is pressure measurement affected by compressibility?
Well, if you have a denser, let's say you're doing if you have a denser fluid, a denser type of thing, the density may end up being, you'll have more density with the compressibility. So you're going to be changing the pressure that's associated with that.
Okay. There's kind of two that went together, maybe. One is, what is HART, H-A-R-T, and the other question that was sort of related was, for remote communications, does the pressure transmitter speak DMP3 protocol in addition to Modbus, and HART?
Okay, so if you look at HART communication, Modbus communication, and these types of communications being mentioned, these are industry standards. ABB offers those, and a lot of other suppliers do, and they're all supposed to follow industry standard communication protocol. That's one thing that ABB really strives to do. These are digital communication profiles. So you have a transmitter that's sending that type of digital signal, and you have a receiver that's receiving and interpolating that digital signal. So they're just digital signals, and ABB believes in a very open architecture. So our transmitters will send that industry standard signal to whatever device you have, whatever you need to do as far as reading that signal.
Okay. All right, the next, we've got just four more real quick. Does your pressure transducer support intrinsic safety application? And if yes, how is this achieved?
Yes, we do support intrinsically safe applications, and it primarily is with the electronics, the amount of power that you're using, the way the construction of the product is. So we definitely have intrinsically safe products, and there's a variety of ways that happens. If you want to know more information about that specifically, there's certification engineers that we use that can go through along with the design team and give more details on that.
Yeah, and you might go back a slide to your contact information in case the person that asked that wants to shoot you off an email real quick. There you go.
Sure.
So Austin, if you want to send him a message, that's great. All right, James asked, would you recommend pressure transmitters for flume applications measuring water flow rates with only inches of water column variation?
Well, as I mentioned before, we do have very low pressure transmitters. I personally have not been involved in an application with really small inches, only a couple of inches, but I would be happy to find more about the application. I mean, with that question, I'd like to know a little bit more about the application, or put James in contact with somebody who could shed a little bit more light on that for you.
Okay, all right. So James, his email is up there. If you would like to email him and give him a little more info, he can follow up with you. This is your chance to get right at the product manager to do that, so it's probably a good idea. All right, next, how is the instrument accuracy affected when remote seals are used or with temperature changes?
So when you're using a remote seal, that's the good thing about the ABB, is when you have an all welded construction through that capillary tube, which can be, only a few inches, or it could be several feet long, but with the all welded seal, and you completely have a filled capillary tube tested with no leaks, you have very, very minimal, if any, effect on your accuracy by doing that. We can, we'd have to pull up a data sheet and go through some of that, but it can be very, very minimal effect with that. So what was the second half of the question, Wayne?
Temperature changes, temperature is affecting it. Yeah.
Right. So typically a pressure transmitter is what we call characterized. So you're going through an environmental chamber and you're applying different pressures at different temperatures. And basically what you're doing is you're teaching the electronics what that actual sensor, let's say it's a piezo crystal, how it reacts at the different pressures and temperatures to stimulate how much electricity is coming out of that. So once you go through the chamber and you do the characterization, the temperature shouldn't really have a lot of effect either. And that's something you'll look at. You'll see people grade their pressure transmitters over different temperature ranges too. So that's how temperature is affecting that. I mean, you have construction of different types of metal, different types of oils like silicone oil, and all that's being used to apply that pressure. And all of those can have expansion and contraction and those types of things. But with the right process and the right characterization and then calibration, it's very minimal effect.
Okay. All right. Let's see. It's 10:44. I'm going to ask one more. There's a couple that I'm not going to ask because I think they're kind of detailed, and I'm going to pass them along to Jim along with your name and have him reply to that. So we'll make the last question today be and you may have to ask, this may also, Jim, be one you have to know a little bit more about, but what's the right location or position where pressure transducers should be installed from a pump?
Yeah, definitely one that'd be good to know more about the application. I'm not sure what industry that is or,
Okay.
what the choices are to apply that, but I'd be happy to look at that and call or email somebody about that.
All right. Well, I will be sending Jim a copy of the questions and the person submitting it and your question very quickly after we end here today, and he'll get back to you as quickly as he can with an answer. He may have to research it a bit. All right. Any final words from you, Jim? And we're going to let these good people go for today.
No, I just appreciate the time that you spent to listen, and hopefully you've learned a little bit, or I've sparked some questions. But ABB has many people globally, and especially in North America, we've got a lot of interest in growth and a lot of people to support you. So hope to hear from you. Thanks for your time.
All right. Thanks, everyone. That concludes our webinar for today. See you at the next one. January 29th, and we have another one on February 12th. That information will be in your follow-up email. Have a good day.